So we're at Lake Norman right now. We're here for tow testing of a 10th scale underwater energy harvesting kite. So it's a unique energy harvesting device that operates on the principle of high lift to drag periodic motion. So basically the idea is you take a high lift to drag wing, we call it a kite, and you fly it in figure eight or elliptical patterns perpendicular to the prevailing flow. And as it turns out, if that kite has a high lift to drag ratio, it can fly many times faster than the prevailing flow speed. And what that means is you get significantly more bang for your buck in terms of the amount of power per unit mass and per unit of material that you would get from a stationary system.
So when we say kite, people are picturing fabrics, and what this really looks like is a small Cessna that you'd see at a general aviation airport. So it's got 4 control surfaces, a port and starboard aileron, which are on the wing. Those are the things you see on the wings, and they go up and down. There's also an elevator on the back of it, which is controlling your pitch. And then lastly, there's a rudder, and that controls your yaw, which will, if you deflect your rudder, the kite's gonna wanna turn. So there are 2 main ways that kites generate power. One's called ground gen, one's called fly gen. So ground gen, which is what we're using on this system, is that kite is attached to a string. And so by generating all that force from flying that figure eight really fast, you actually can spool out that winch, and there's a generator on the winch harnessing all of that force that you're spooling out with.
For this implementation here, we had to integrate equipment from the lab space with existing configurations on the boat to create that winching mechanism. So the winch mechanism itself really is just an electronic motor with an inline torque sensor coupled to a drum and then a level wind mechanism. So we provide power and winch commands to this electronic motor. We can rotate that drum at certain speeds for certain periods of time. The tether comes off that drum assembly. It wraps around a roller fixed to a load cell, and that's what gives us a tension reading, because that is important for quantifying how much power is generated, as is the torque sensor there. It's kind of a dual verification system. You can measure torque directly exerted on the drum, but we can also look at the tension in the tether, and that will also give us a gauge of how much frictional force is taking place within the system, because there are improvements that could be made to this system. But after the tether comes out the load cell, it goes to the top of a vertical boom, which is attached rigidly to the side of the boat, pointed straight down. It turns 90 degrees through a cuff mechanism, just goes straight down. And then we have our line angle sensor, which is where the tether leaves the boat. And that line angle sensor just allows us to measure an elevation and azimuth angle to essentially track motion of the kite.
What we're working on here in this experiment is what's called orientation-based cross-current flight. And so we have what's called an inertial measurement unit on the kite that's measuring its orientation in space. So take the kite, you can spin it in a couple different directions, and it tells you exactly how it's oriented relative to the Earth. And then by making time series set points, you can actually track a pattern. And by doing that, you can trick the kite into flying figure eights.
What's really exciting about this project is that if you go back just a few years, we were involved in some initial seed funding, flying 3D printed 1/100th scale models of kite systems and other tethered energy harvesting systems in a water channel. And now, just a few years later, here we are testing a larger scale system for hours at a time in the open water. And the ability to get from there to here is really thanks to a lot of efforts. Certainly the efforts of the people on the team. I mean, that cannot be understated. But also the support of the North Carolina Renewable Ocean Energy Program and the support of agencies like NSF, who have sponsored a lot of the initial fundamental research that's gone into the really exciting testing that's going to be happening today and over the next few days.